What's splashing? Welcome to season 5, episode 4 of Siren Sundays with me, your host, Lashanti the Siren. This show is focused on speaking with researchers, scientists, and practitioners of environmental science and all things conservation. You are now tuning in for our conservation conversation. Today's guest is Marjahn Finlayson, a researcher from the Cape Eleuthera Institute at the Island School. Welcome.
Thank you. Great to be here. Very excited.
It's great to have you to talk about such an important topic, hurricanes and climate change. I know a lot of people, this big truck. Can you, I don't know, you gotta love live TV. Anything can happen. Anything can happen. Right. But so hurricanes and climate change is actually a very interesting topic and a very important one for the Bahamas. So I'm so happy to have you talk about that today. But before we jump in, can you introduce yourself? Tell us who you are, what you do.
Okay. Yep. I'm Marjahn Finlayson. I am a researcher at the Cape Eleuthera Institute at the Island School, just like Ashanti just said. I focus primarily on climate, climatology, atmospheric science, and that includes meteorology. And we also do some work that involves physical oceanography. My expertise really is in tropical cyclones and climate change. So happy to talk about it.
That's exciting. So can you tell us just a brief intro of how you got to where you are? Like what made you choose the path of this atmospheric science and climate change and all these other things? Is it something from your childhood that inspired you, or did you just knew what you wanted to do?
So when I was a kid, I wanted to be a tree hugger so badly. Like that was like my goal in life, to get chained to a tree, because Captain Planet just inspired me. I was just ready to go. So I was always going to go into environment. I just didn't know where. So in university, we did some work that was basically just rock-based geology stuff, which was cool. And I liked the physics of everything that related to that. But it wasn't until we took a class on ocean and atmosphere where I was climate modeling for a little bit, where I realized this is the only thing I ever want to do with my life. So I did that. And, you know, when I first went off to university, I can't remember the hurricane, but it literally was going up to Connecticut where I was going to school. And I was kind of just like, okay, this is weird. Why is this happening? I didn't know at the time, like where hurricanes hit and like pathways and all that. So I was really interested in that. And then the next year was Superstorm Sandy. So I was like, all right, something is happening with the hurricanes and the climate, and I'm going to figure out what's going on. So that was really what got me involved in this.
Yeah, and we do have a comment from T. Clark. Captain Planet inspired a lot of people. He sure did. I always wanted one of those rings and summon this magical man or woman. You know,
I wanted to be water so bad.
Me
like,
too.
Right?
Right? Like naturally, right?
Exactly.
But, so I know we briefly said the words atmospheric science. Can you just break down what is atmospheric science?
Okay. Well, to answer that question, there is focus on what is the atmosphere, right? So if you talk about the different spheres, there's the biosphere that focuses on all life on Earth. You have the lithosphere that focuses on like the different layers inside Earth. And then you have the atmosphere, which are these layers of air that lies in between Earth and outer space, right? So everything that's going on in between Earth and outer space is what we study, and how we interact with it on Earth. So the different layers of the atmosphere is something that we care about. So you look at like different things going on in the troposphere and stratosphere, mesosphere and thermosphere as you go higher up. But for purposes, current purposes right now, a lot of climate scientists are focused on the troposphere and stratosphere, because those are what we immediately interact with to get an idea of things going on. So you can study things from like cloud physics to how phytoplankton like breathe out and like have more oxygen release.
Last episode.
Yes. Shout out to Catalina. You could study all kinds of things in atmosphere. So one of the biggest things that I like to look at are ocean and atmosphere interactions, which is really essentially hurricane stuff. So
right. Yeah, I know one of the things that even I found was interesting when I was studying marine biology, and that when I told other people, they were like, "Oh, really?" And I'm like, when you study marine biology, you actually end up studying the weather, and people don't realize this big impact that the ocean has on our weather. We just think it's just this body of water, and everything else is just the sky, but it's actually that interface between the sea and the sky that is really, creating the weather that we experience. And yeah, right. So, can you tell us what is this connection between obviously climate change, and this atmospheric science?
Okay, yeah. What I like to tell my students about how climate works, weather has to come from the four elements. Like, I like to relate it back to Avatar: The Last Airbender, right? So you have your fire, which is the sun. You have water, which is ocean. You have your wind, that basically is a function of the sun, just carrying heat to different areas. And then you have earth, right? So you have like things that have trees affected in the same way. That makes a difference for how our weather works. Now, the weather would be the day-to-day that happens. The day-to-day changes in the atmosphere would be our weather. When we talk about climate, we're talking about the long-term changes and the long-term state of the weather. So we could look at, and things that affect that would be like which region you find this weather, like particular climate. So like here in the Bahamas, it's normally warm because we're closer to the equator than, let's say, Connecticut, right? And then time of year, seasonality, where the earth rotates, how the earth rotates, the kind of axis that the earth's on. So the earth's axis can change. It changes its angle every, and I could be wrong about this, every 11,000 years or so.
Mm-hmm.
And that's known as one of the Milankovitch cycles, which actually naturally affects the climate everywhere. So if it goes up by a little bit, you might see a change in one of the poles. If it goes lower, and it only can go between 22 degrees to about 24.5 degrees. So it's a very small change, but it is something that's noted in paleoclimate studies.
Mm-hmm. Which is important. And I think something you said is also an important point that a lot of people don't realize. When we talk about climate and climate change, it is very long term. It's not the day-to-day weather that we see, because even when it comes to like the hurricanes, which we're going to be talking about, when we look decades ago, we have what we can compare to, not so much as, oh, well, last year and then the year before. Like, that's too short of a time frame when we talk about things like climate change and even the increase in these hurricanes becoming stronger. But before we dive into that, can you just briefly explain, how is a hurricane formed?
Okay, so hurricanes, it depends. Dr. Wayne Neely has a book out that's really good that explains how hurricanes form, well, hurricanes in general. He has like 13 books. That's his life. Just definitely look him up. But yes.
I'm trying to get him during hurricane season this year.
So he has great information on it. But basic hurricane formation, from what I studied, our hurricane is you'd have an easterly wave, which is really an invisible bit of air that moves across off the the West African coast. So what would happen is you have some storms that travel like in convective storms. So you have these really big clouds that come from these thunderstorms that kind of travel around as they go and meet this wave. They just travel across the main development region in the area. So across the Atlantic Ocean, there's a main development region that is normally 10 degrees north to about 20 degrees north, 0 degrees in general with the equator, and then about 100 degrees west, right? So the storm would normally travel over this piece of sea, and the sea surface normally has to be very warm because it acts as fuel for the convective system to continue as it travels along. Then it starts to swirl a little bit as it goes. So because of this thing called Coriolis force, the storm will start to swirl in a counterclockwise direction as it travels along. And it's very important that there are large environmental factors around to keep the storm maintaining its development, but also like if it intensifies, what are one of the reasons? So humidity is something that's really, really big. In the middle of the troposphere, it's very moist, it's able to keep the storm like either developing or getting more intense. One of the things that's huge is vertical wind shear. If we have more of that, and normally there's more vertical wind shear around like January, April, December, so you wouldn't see much tropical storm development because of that. It hinders hurricane development, it hinders intensification. So we see less of it during May to November, which is closer to hurricane season. Sea surface temperatures also have to be very, very hot. So above 26 degrees Celsius. It has to be extremely hot because it acts as a fuel for the storms, as I said earlier. So what we're looking at now is with climate, we're worried that as sea surfaces become warmer over time, right? Especially during the May to November period, what will happen to the tropical cyclones? Will they become more intense? Will they become more frequent? Are we going to see more vertical wind shear or less? What about the humidity? Things like that all make a difference. And what we're actually studying here now, one of the bits of research that we're looking at is looking at how sea surface salinity also has an effect of tropical cyclone intensification. So, yeah, interestingly enough, when it comes to hurricane studies and basically tropical cyclones in general, the North Atlantic basin where we live and we're the most affected has the longest record, but it's still a relatively short record. So we're not really sure what's going to happen in the future because we don't really have a good idea of the past. So there are actual studies like paleotempestology, which is the study of hurricanes in the past, looking at like different cores and sediments to get an idea of what happened way back when with huge hurricane events. But even then, there's still not enough information. So everything that we kind of do in this field is it's semi-groundbreaking in the fact that people really don't know what's going on. Right. There's a lot of uncertainty, and I'm going to use that a lot. So uncertainty is it's the key word in this kind of study.
Yeah, and I know one of the most important things that people kept saying, even when we had Hurricane Dorian, is this is the strongest documented hurricane, because a lot of people are like, we really don't know, and we don't have enough knowledge to really determine if there was a hurricane just as intense or even more intense, just simply because we just don't have the information. And then in life and in science, that's why it's so important to just document these things, because it benefits those future generations. So we don't have it, but we're trying. And even just now that we're keeping record, it's still kind of helping us, I'm assuming. And given that we know how climate change is going, we'll see what happens. But last definition, I feel like I've been turning you into a dictionary. But, I just think it's so important to really flesh out these terms, especially because there's a lot of misconceptions with them. And I know climate change, which was originally referred to as global warming, got this name change because, and you're going to tell us why.
So climate change, global warming was too broad a term, right? Because not everywhere in the world is it warming. And you have a lot of climate scientists who are like with everything, right? You have like a left and a right, kind of. So you have some climate scientists who would explain the trend of global warming as something that's not entirely accurate. So we lean more toward the middle when we talk about climate change, because truthfully, that is the case. So climate change is a change in the long-term conditions as we've expected, that we've been experiencing for a long period of time. It is a very natural process. However, what makes us nervous is the rate at which we're seeing the climate change. So what would have happened in the past is, if you look at Earth's record, long-term history of how long Earth has been around, not necessarily humans, but the Earth's geologic record would have shown that there are theories that would have been saying that earlier on, there had been like ice age that happened. We were in a glacial period. Then Earth warmed up over a couple, I'd say 10,000 years or so, Earth warmed up. Okay, that's fine. Everything's hot. I think there are models that kind of show that the Antarctica used to be like a very tropical place, like in paleoclimate. And then there's another ice age. And I don't know how many ice age movies you can watch where you get an idea like ice ages happen and then we warm up and then there's an ice age and then it happens. So right now we are again in another interglacial period. So what that means is simply like there's one ice age that happened way back when, there's another one scheduled to happen, but we're hitting a point between every interglacial period, you hit a point where there's the highest temperature you can get. So that normally should take a longer period of time, maybe 5,000 years, could be 10,000, could be 2,000. What's happened now with climate change, and we refer to it as anthropogenic climate change because it's human influence, most definitely.
It's us.
So what happened in 1850, once there was use of like we move away from steam engines, we go to more coal-based things. Well, I guess move to steam engines. There were scientists who already had calculated, and again, climate science, atmospheric science involves a lot of math, so they would have calculated and done some modeling to show that there is going to be an imbalance of the amount of air and carbon that goes up in the atmosphere if we continue along this path. And that was 1850. So they were aware that
they knew from then.
Yes. So as technologies got more serious, then you see that there was an imbalance and increase of carbon dioxide as it went up into the atmosphere. And so basically what happens is carbon dioxide, methane, nitrous oxide, they all go up into this blanket of the atmosphere called greenhouse gases. And greenhouse effect is basically where you have long radiation that comes from the sun, hits Earth, heat is absorbed by Earth, and some of that shortwave radiation is reflected back into the sky. The greenhouse gases are supposed to absorb some of them, some of the rays, to keep us all alive, because we need heat to survive. But the issue is there was normally a hole in the blanket, the greenhouse blanket, where some of the radiation could go back into space. With more gases in the atmosphere now, though, we're seeing those atmospheric windows, those holes close up because there's too much greenhouse gases.
Right.
So what was a very natural, important thing, like we can't have all of the heat escape back, go back to space, or we will die.
Right.
So what was a normal process that should have been happening with the promotion of more technologies over these years, we've seen more heat, and there's been an imbalance in Earth's energy budget, heat energy budget.
Right.
And that's basically what anthropogenic climate change has done, which creates these crazy climate feedbacks that we expect some permanent change to different Earth systems. I think they just said that that the damage that was done to the ocean in 2014 is irreversible now.
Oh, this is so sad. And just like I spoke about, Catalina and I spoke about the movie that came out on Netflix, Don't Look Up. Mm-hmm. We're here, like we're so here, like the conservationists, the climate scientists, we're shouting, and nobody's listening, and it gets depressing, but there's still hope. But I know we have two questions. Well, one question so far in the audience, and let me know if you can answer it. What is the difference between a water spout and a tornado?
I could not answer that well. To the best of my ability, I could tell you they're both very small cyclonic systems, but they're both small cyclonic systems. So water spout would happen more when you're around ocean, tornadoes, middle of nowhere, more wind effect than anything. But again, I couldn't answer that that's the best answer.
And I was like, I feel like we stretched a little with that one, but I do know, I always say the difference is one happens on top of the water, the other happens in the land, in the middle of like nowhere. So thank you for that. And I know we do have a comment from Ashley. I don't think the mass public understands how much climate change is affecting the world every day and how serious it truly is, especially here in the Bahamas. And even to that point, I think what's so unfortunate is the Bahamas has such a small global footprint. But we are being hit so hard and so regularly now. It's really hard for us to even, we can't make a change as a nation. The only thing that we can really do is put our foot down, get up on that soapbox, and really appeal to these other countries and hope that it gets better.
A lot of hope.
I did have another question, and this is something I thought about as you were talking a bit earlier. I know there's this like old folklore, Bahamians have a lot of cool like folklore from the older generations before actually hurricanes is getting properly documented, where I've heard that if we have a lot of heavy rain before hurricane season, the water is cooler and we don't expect as many hurricanes or as intense of hurricanes in the season that follows. Is there any truth to that? Any scientific evidence? Has anyone ever looked into that?
I don't know. I'm not sure who could. I don't know if I've seen anything related to that could give an idea. It is a good thought. The only issue is the way that sea surface temperature really works with months and all that. You remember air and water, both active fluids. So air, whenever you have hot air, water is going to be warm as well. And it takes a longer time for the water to cool down than it does for air. And then we also have to depend on where ocean masses go and travel too. That also makes a difference in terms of like sea surface temperatures being warm and cold. So the precipitation may have a short-term effect, but I cannot see it being a big change.
Yeah. That's, and I always, I'm just like, oh, it's raining plenty, man. We ain't have no bad hurricanes. Right. So we do have one more question, and I will, I think it's two more now. So Innocent Fugitive on YouTube asks, what can we expect from hurricanes as climate change worsens?
Oh, okay. That I can answer. So,
thanks, Innocent Fugitive.
Yes. So what we can see with climate change, right? We know that global mean temperatures are increasing. Sea surface temperatures are getting warmer. It's become like ocean heat content is even more hot than it used to be. So we know that for sure. We can expect there are going to be hurricanes. The other thing is that as we see more intense heat happening within the ocean, we also expect there's going to be more vertical wind shear during the seasons. So we're expecting more vertical wind shear, more specific humidity, not really relative because it's affected by temperature, but we expect to see more humidity in the atmosphere. We expect to see warmer waters, and we also expect to see more vertical wind shear that is a hindrance to hurricanes. So what we think, and this is like all of hurricanes climate folks, we assume that we can expect more intense hurricanes in the future. So we do expect to see more category 4s and 5s, but not necessarily more hurricanes, if that makes sense. So it wouldn't be more frequent hurricanes. It would be more hurricanes that are just stronger. And we're looking at the rapid intensification now, because as you would have noticed in the past 2 hurricane seasons, so 2020, 2021, the hurricanes were like Hurricane Laura in Louisiana, that went from like a 1 to 4 in like hours. Hurricane Dorian, like 1 to 5 in a second. You know what I mean? So now what the hot topic is for most scientists now is looking at the rapid intensification. What's happening? And so we're also trying to get an idea of where sea salinity, sea salt really plays a difference with that. So what we're finding out so far, right, and there are papers that are already on this, is when you look at the salinity content in a specific water mass, if it's less salinity, we can expect that we're going to see storms wouldn't intensify as quickly, right? So it wouldn't intensify, but if it's more, we'd see more salinity. So what climate models are trying to do, and this is another thing that adds uncertainty, right? So with my research, one of the things that we looked at are the atmosphere-only models that has a prescribed sea surface temperature. It's already set, it's not going to change for a bit, and it doesn't acknowledge all of the ocean atmosphere interactions, but it gives you an idea of what the dynamical ways that hurricanes interact with the ocean in a set environment. So we have an idea that with all these things, you do an ocean atmosphere model to get an idea, but there's still a degree of uncertainty. So what we're trying to do is record data, so sea surface temperature, sea surface salinity, and put that into our newly resolved models, because again, running models is so expensive. So what they have to do is make really, really high resolution models in different places. And now we can actually add more ocean data into these models, which helps with the atmosphere ocean models to give a better idea of what could possibly happen. So the National Weather Service in the US, the Hurricane Center, uses that data to actually get an idea of how intense tropical cyclones are going to be given a season. And so what we want to do is look at the long-term effects into the future with the same data.
See, it's interesting, and I'm going to throw it back to some folklore. It's interesting that you mentioned sea surface salinity, which, as you explained, is the amount of salt, right? The percentage of salt in the surface of the sea. And just to take it back to that whole a lot of rain, right? Because if we have a lot of rain, the sea surface salinity does decrease. So I wonder if that has some relevance. I'll throw that out there for you climate, researchers to do. We do have 2 comments about the other folklores. I don't know if you've heard these. And Denise Jepgram says, my aunt. And what about the blossoms on fruit cheese? Is that an old wives' tale? And we have Dorlan Curtis, who comes from YouTube, saying there's also folklore relating to bountiful mango and avocado season correlating with active hurricane seasons. I know I've heard that. It's like when you start to see a lot of great fruit producing, like it's a sign that, hey, it's not going to be a good one. Has there ever been any studies on that?
No, I've definitely heard that from my Grammy though, but yeah, I couldn't answer that one.
Yeah. And like I said, these are all like, our older informal scientists. But we have one more comment from Facebook from Denise Jeb Graham talking about an article she saw earlier today about melting of the glaciers due to climate change and the disappearing of islands. And so that, as we know, is the sea level rise that we are at risk of. So I know the next thing we want to talk about is some of your research. I know you started saying the sea salt. Look at me saying it now. Sea salinity. Stay scientific. The sea salinity is one of the things that you guys are looking at. Are there some other things that you guys are doing at the Cape Eleuthera Institute at the Island School pertaining to climate change and hurricanes and atmospheric research?
Well, we have a lot of work that we're currently trying to do. We try to focus on climate studies and trying to introduce that more into the curriculum. So what is climate? What is the climate that we have in South Eleuthera? We're also we want to build off of one of the pieces of work that we've started with the University of the Bahamas Climate Change, Adaptation, and Resilience Research Center. Dr. Adele, yeah, I have to remember it. We've started doing some work with them. We put out an information brief last March about how climate change relates to the Bahamas, and I can send that to you. Just a small information brief so folks know what it is, and you ask how is it going to be, like what should we look, like what are we going to look forward to in the next 10 years or so. I'm not really forward, but worse words used. And then we're also doing some work where we're trying to piggyback off of some work done by Dr. Adele Thomas and Dr. Lisa Benjamin on getting perceptions of climate change. That's one of the things that we hope to get, soon. Just understanding like local folks' understanding of what climate change is and where there are education gaps and where we can fill them. Right. We also do work with, for meteorology, which is a branch of atmospheric science. We are one of the community, there's so many acronyms, the COCORAS network, the Community Collaborative Rain, Hail, and Snow Network. We work along with them to collect data, rain gauge data. So we put that information in just about every day, just to see like, it rained today, it didn't rain today, it rained today, it didn't rain today. We maintain a weather station here that we try to keep up for South Eleuthera. We work with One Eleuthera Foundation to make sure that we both have our weather stations set and ready to go. And finally, we do our underwater sea glider work. We're taking data every hurricane season just to see what the sea surface temperature and salinity is like. And we do that in a collaboration with the University of Miami. And through them, we work through the University of Miami. We're able to work with folks at the National Oceanographic and Atmospheric Administration. NOAA. And yes, NOAA. So many acronyms. And then finally, I'm working on some research that focuses on tropical cyclones and how they're going to be affected by climate change by the year 2050 using a high resolution model. And I'm doing that work with folks at the University of Reading that I started at the University of Leeds.
That was a mouthful. I feel like I want to give you a round of applause for all of that. It's a lot going on. And it's really exciting to hear that this research is being done by a Bahamian in the Bahamas, because I think a lot of times, as you know, when you grow up here and you get interested in any sort of science, the immediate go-to is go be a doctor. Go do that,
Yes.
Yeah. And we're not all destined to be doctors. We do have an interesting question from the Innocent Fugitive again. Did you see the study, a neo-Arctic, neotropical migratory songbirds nesting phenology, I think I might have said that wrong, and clutch size are predictors of accumulated cyclone energy? And if you did, what did you think?
I did not see that article, but that is really cool. I think I need to put this out there. I am not a biology person at all. I really am just a physical scientist. I don't really know that much. I'm learning every day. I watch Siren Sundays, so I get an idea of what's going on in that world.
Right. So I know they followed up with, more generally, are there any local predictors that we can use that work?
To watch for hurricanes.
Yeah, predictors of, I think, the cyclone energy, climate change, and hurricane.
I could not answer that question, I'm afraid. When it comes to ACE, accumulated energy, that is something for, I wouldn't be able to answer that question. I have a colleague, Jordan Jones, who would be more excellent at answering that question. But I definitely could put that through to her.
Yeah, and again, if anyone wants to connect with Marjahn, up top above her is her Twitter, and not only for her handle, but also for CEI Bahamas. So definitely follow those pages, and you can find out ways to contact her, contact the Institute to get some of this information, because they are very happy and very ready to share all the work that they have. And I know the last question from the Innocent Fugitive is, where can we read your work? Do you guys have these on your website? Are these papers published somewhere with open access that people can go and read?
Yes, the climate brief should be available on the CEI website, on our blogs, I think, blogs and publication. You should be able to see some of that. I have a lot of stuff. A lot of our work that we do in the field is on their CEI blog. So you would see information about what we did with the glider. The first launch was last year. And our recovery date, what we did there. I have information on how climate change will affect Eleuthera. It's all on the website.
Right. So I did just pop that website in the link for those of you that are interested. Feel free to go mosey on down to that after the show. We still want the rest of your attention. We have a few more topics to get into, which is one of the most important ones. How can people who are watching either get involved or help out you guys with this research that you're doing?
Well, definitely follow CEI Bahamas, follow me. We always have a call for action, ask people for assistance wherever we can. We do appreciate help from citizen scientists and folks who want to work with us. We also are big on teaching. So just so folks know, part of the work that we do at CEI is we work with folks who are international and also local students to get them to understand things that are affecting work in conservation, biology, fisheries, but also climate change is the newest thing that we're working on now. So we love to do outreach and community engagement, so definitely give us a shout.
Right, and I think in the COVID climate that we're in, virtual is very possible, so definitely hit them up. Even if you're not based in South Eleuthera, there are many ways these days, as we've learned, to connect and get some of these presentations done. And another thing, what do you guys offer any sort of internships, and what do you need to have to kind of qualify to intern at the Cape Eleuthera Institute at the Island School?
Thank you. Great. What we do is we do offer internships for the spring and the fall. I think those are 3-month-long internships that happen here. You'd really only need, I believe, a bachelor's degree, maybe a love for the boats and not getting seasick. Really big thing. And it's just a love for the science in general. So if you are interested in working in conservation, atmospheric science, sustainability, agriculture, definitely look us up. Look at interning. We love having Bahamians here. So definitely apply if you are interested. We also offer a summer internship that I believe is, and Dorian can correct me in the comments, I believe it's a month and a half or it's a month. I'm not sure though, but we do offer summer internships as well. So if you're interested in coming here in the summer, definitely apply. We'd love to have people down here.
Definitely. And again, you can use that link to their website to find out about all those opportunities to get involved with the Island School. I know I love Eleuthera, so I definitely hope the next time I visit, I'm going to come and visit you guys and hang out with you for a bit. I think I've had so many people from the Island School on my show. I know, and yeah, Dorian says it's June to August. I'll pop that there, the summer internship. But I ran into Dr. Nicholas Higgs during the conclave, and he was like, "You keep interviewing my staff. I feel like I need to give you a job down here." And I'm like, I'll just interview your staff. They're all doing such great things. And yes, and so the deadline for the summer internship is March 1st. Thank you, Dorian, who will also be back on the show to talk about Food Post Farms in March. He coming back. So
it'll be good. It'll be good.
Yeah. So I know as we start to close out, can you give us maybe like a final thought, a life lesson, right? Like from the work you've done that you'd want to share with the viewers?
Definitely. I think the one thing I'd share with folks is based on the work that I have done, there have been a lot of obstacles to get to this point, right? So just getting the education, working to get to this place, trying to build up, like I saw something I wanted to do and I had to kind of push for it for a long time to get here. And I'd say to folks, like, if you want something, you should go for it. There will be obstacles that you have to face, but one of the biggest ones shouldn't be yourself. Don't stand in your own way and limit yourself, because there's so much you can do.
I love that. Don't stand in your own way. That's I feel like all my guests have such amazing life lessons. And to be fair, I really do these for me. Like, my viewers can benefit, but I love just hearing, you talk about your work and then just like some of the life lessons you've learned. I know before we went live, you had mentioned the Black and Geo spatial. Ooh, correct me because I'm messing it up. Can you talk
The
to me about it?
hashtag Black in Geoscience.
Yes.
Yes.
And so is that, do you find that there are not a lot of Black people or even maybe Black women in geoscience?
Man, so what?
Girl.
Especially in atmospheric science.
Mm-hmm.
So Black in Geoscience was born out of the 2020 protests that happened. So what happened there is we saw, like, George Floyd, we saw more protests, and folks in different spheres of every science world was like, we're going to do Black in this science. We're going to do Black in this science. So a lot of us who were in geoscience kind of came together and were like, let's organize a thing. So you have people who work in dirt. You have people who work in atmosphere. You have people who work in hydrology, all coming together all over the world, trying to figure out, like, what do we do? And just trying to bring an idea of what kind of obstacles that we face as Black scientists. For Black female scientists in atmosphere, I can say that I know Jordan Jones. That's my Dr. Jordan Jones, my girl. There aren't many Black, and she's also a Caribbean person as well.
Oh, I love it.
Right? So we're both into tropical cyclones. The issue that we face when it comes to atmospheric science is, especially for women, there is the math physics element of it. So, there are studies that show, like, as women branch off into STEM, it's harder to stay in because it's a little more discouraging as you get into these physical sciences. So where we have more women who are fantastic in biology, love seeing everyone in chemistry, love seeing people do their work. Once you get to the physical, like, math element, it's a shutdown. It is a very white, male, cisgendered world. And you're just trying to make your way through it. So for me, a lot of my mentors have been really, a lot of them have been like white women and some women of color, but not really any Black women in this field so far.
Wow.
And yeah, there's been a lot of, in my experience, where I've worked and where I've been educated, there's been a lot of push to try to get more of those voices in these spaces, especially coming from a small island developing state, where when it comes to atmospheric science, especially if you look at like IPCC reports and things like that, they are coming from these places that are like Germany, England, America.
Yeah.
You barely, and like sometimes you'll hear from like folks who work in Jamaica in the high resolution labs there, Cuba. You sometimes hear from those folks, but I can say for the Bahamas, we have one person who is always whose name's always brought up in the international realm, and that would be Dr. Adele Thomas.
Okay.
When it comes to like this climate change reporting, because the rooms they're so not reflective of the people who are going to be hit by climate change the most.
And that's important. That's so important, because even like when you think about just a lot of things that deal with just like populations and people who are being affected, the people who are making decisions and the people who are studying these topics are rarely in the demographic or even in the countries that are being affected. So I hope that you have inspired more Bahamians to get involved with anyone else, and again, any Bahamians listening who may know someone who's great at math and physics, hit her up, because you have a path clear cut for you to go into atmospheric science. I know I just saw a question pop up from McKenna Gray on YouTube. What has been your greatest challenge in pursuing this career and getting to where you are now? And they also note that you are an inspiration. You really are.
That's one of my old students. Hey, McKenna. Greatest challenge in pursuing this career. I think one of the personal challenges I've had getting where I am is, again, kind of standing in my own way. And not really, and my mom pointed this out to me one time, and she's watching, but you have to be able to ask for help, right? So one of the things that I really struggle with now is like even asking for help. One of my advisors one time was like, you have to stop suffering in silence, because I will find every solution and everything I can fix by myself. But there are just sometimes where you have to stand out of your own way, ask for help, and do the thing. So holding myself accountable and doing that has been a struggle, but I'm working on it every day.
Yeah, that's important. I think that's
Mhm.
just we oftentimes we have to be so independent and strong that it's very hard to let go of that independence and really even just trust your work with someone else, and even just like unloading your burden right onto
Yes.
someone else. So it's definitely, that's a great piece of advice, and I think that's why it's so important for us to connect. Like scientists in the Bahamas, we need to connect, especially women in science, Black women in science, anyone in science who's interested. I think it's so important to just build these connections. And so one of the things that I did with this show is I just wanted people to be seen, and I want people to hear about each other's
Mhm.
work and connect with each other. And I've actually had that happen sometimes where a student would be watching a researcher and then they connect and they're like, oh, because I heard about you on Siren Sundays. And I'm just
Mhm.
internally glowing because I think that's my life purpose, to build this community.
You're doing great.
Oh, thank you. So we
Yeah.
do have one more question, and I don't want to keep you too long because we're just getting on that 40-minute mark. Innocent Fugitive asks, how did you feel about the efforts to diversify? Are there things you see changing or not changing?
In terms of like Black and geoscience and things like that, we mean?
I'm gonna guess that efforts to diversify the community.
I think it depends on where you are. There are different efforts that have to happen, right? So what I saw the other day was, that's my sister. What I saw the other day was when I worked, so I had an internship where I worked at NOAA. There are a lot Geofluid Laboratory in Princeton, New Jersey. That was really cool. What an experience. I was the only Black person in the room most of the time. And it was very obvious. So the person I worked under at the time, I was interning for Dr. Becky, tropical cyclone genius, knows all the things. So I was the only Black person. And I think there were some folks who had come from, who were scientists from India, who connected with me based on the fact that we were all not white people in the room. But there were no other Black scientists there. And it was very obvious. It was kind of weird. The only other Black person I think was somebody who worked in the computer technology support, who was like in himself, what a success, because those computers are huge. But it was just me. It was just me in the actual like climate science like department. And the other day I saw that they actually hired someone, an actual a Black PhD who works there now, a doctor in his own right. And it's just, and he got there through a STEP program, I think, that they do for African Americans in the US for like more Black persons to join NOAA. And it's a program that they've done to push for that because they recognize that it was like, and when I was there, that was 2014. So in 2021, there's been a change that's huge. I can also say that in England, again, it depends on where you are. In the US, it's something that they've addressed because it's been said. I think culturally, when I was working in England, that was something that was too uncomfortable to talk about because for them, the biggest effort was getting women, but we don't know what, you know. So I remember I had to sit with a professor once and say, okay, I understand that you get that I'm having a hard time because I'm a woman, because you are also married to women, but I'm also Black and things are different for me. Like people have asked me, are you sure you're in the right place? So there's like definitely a culture thing where it's weird. So I think it depends. I think for a lot of Black British folks, finding the voice, like after the 2020 riots, a lot of them have found the voice to actually say like, this is a problem. Because like I was unruly for saying like, guys, we have no Black people here. Like it was unruly. It was like unheard of.
Yeah.
But like in the US, in NOAA in particular, I know that they've been making strides to see some change.
Awesome. That's great. It's good to see, you know, that it's being heard and it's being changed. I know, just to close out, final question. Who, we love the microaggressions. Thank you, Tiffany A. Bain. Who is someone in the sector, whether it be local or international, that inspires you and why?
I will say locally, it's Dr. Adele Thomas for me. She's always been a strong advocate of having more Bahamians, but particularly like Black women doing important work in climate change. She's more in the social climate change aspect than she is rather than physical, but she's always been a listening ear to me. She's always so helpful. And again, like when I was talking to like my advisor in England, who was like literally like in Leeds, who was like the incoming director for like this huge institute, she was just like, but you've met Dr. Adele Thomas, right? Like she is just the greatest thing since sliced bread. You know what I mean? Like this is somebody who's from this island, who's like a huge inspiration to folks all over the world. and she has like the time to talk to us. Like, what a person. So she's been a really, like, in my experience, like personally, but also professionally, she's been an inspiration. She's been a mentor. And I'm so excited to still like know her and speak to her.
Oh, that's great. Awesome. Well, we're almost out of time, but I thank you so much for being on this show. This was such a great episode. I always love when I get to talk to you guys on Sundays. Thank you all who were watching for riding another wave with us for another episode of Siren Sundays. To all of you who are viewing live and asking questions, amazing. And yes, we have a shout out to Dr. Thomas. Definitely, I gotta meet this a doctor. Like, I think she should come on the show one day.
She should.
Yeah,
she's great.
She sounds to be great. So hopefully, if you're listening, Dr. Thomas, I'm going to come and find you and put you on the show. But yeah, and so all of you who are listening on the podcast later, thank you for tuning in. And those of you who would like to watch this again later, it will be up on Facebook, YouTube, and on all podcast platforms. And we have so much from the audience. I have to make sure that everyone's seeing all these hand clappings. Such a great show, wonderful show, awesome show. And it's only because I have such an amazing guest. So thank you so much.
Thank you for having me.
Spending time on this Sunday to just chat it up with me.
Yes. Anytime.
Awesome. Bye, everyone.